Greetings and welcome to yet another video. Today we'll discuss about the diagonal scale. In the previous video we discussed about the plane scale in engineering drawing. In diagonal scale, a short line can be divided into small divisions by using the principle of diagonal divisions. The principle is diagonal divisions. Now, before actually constructing a diagonal scale, we should first understand the diagonal divisions. For diagonal divisions, the ratio of corresponding sides of similar triangles. These properties of triangles are necessary. So just to recap from the school levels, suppose we have a triangle ABC. This is a right angled triangle, but this is true for any triangle if the triangles are similar. Suppose D is the midpoint of line AB. Now, if we draw a line DE parallel to the line BC, so the line DE is parallel to the line BC and D is the midpoint of line AB. That way we get two triangles. One is ADE and the origin one is ABC. These two triangles are similar triangle. Now for similar triangle, we know the ratio of the sides, like say DE divided by BC. That means ratio of the sides, corresponding side of the two triangles is equal to AD divided by AB. AD is equal to half of AB because D is the midpoint of line AB. So we get the relation half of AB divided by AB, and that is equal to half. By using the properties of similar triangles, we get the ratio DE divided by BC. So from this relation, DE is equal to half of BC. That means if we know the line BC, length of the line BC, then we can find out the length of the line DE. And this is true for any other point. Say F is a point in which AF is equal to 1/7 of AB. And if we draw a line FG which is parallel to line BC, then we will get F is equal to 1/7 of BC. So this is the principle of similar triangles that will be used in principle of diagonal division. So let's understand the principle of diagonal division. In diagonal scale, it represents 3 units. It may be 3 units like kilometer, hectometer and decameter, the consecutive units. Similarly, meter, decimeters and centimeters. In some cases, it may not be 3 units, but it may be 2 units and a fraction of the second unit. So that way, a diagonal scale is very useful for measuring 3 units or 2 units and a fraction of the second unit. So this is an example of say diagonal scale. Then if we measure the meter in this side, then this division will be, if it is meter, then it will be decimeter, and this way vertically we will get the centimeter. So we can measure correct up to 3 units. That means a diagonal scale will represent 3 units and minimum of 2 units and 1 fraction of the second unit. So let us understand the principle of diagonal scale first. Suppose we have a line AB and we have to divide this line AB into 10 equal divisions. We can see AB is a short line and this line can again be divided into 10 divisions. We will use the principle of diagonal divisions. So let's draw a line CA perpendicular to the line AB. And we can take the length of the line CA conveniently to divide it into 10 equal divisions. Suppose we divide CA into 10 equal divisions, and we can do it conveniently for CA. We can take any length of line, but we have to divide line AB into 10 equal divisions. But for CA we can take any length, convenient length. Now mark these divisions like 1 dash, 2 dash, 3 dash up to 10 dash. So we get 10 equal divisions. Now join the point C. By joining the points C and B, we get a triangle, and this is a right angled triangle. This is a right angled triangle. Triangle CAB. Now we can draw line parallel to AB through the point 1 dash, 2 dash, etc. Now let us draw all the parallel lines through point 1 dash, 2 dash, etc. and which are parallel to line AB. This way we get 10 additional triangle smaller than the original triangle CAB. And let us mark the points like 1, 2, 3 on the other side of the triangle. So if we look at this, we get C1 dash 1. This is a triangle smaller than the triangle CAB. Consider the point 5 dash and 5. The line 5 dash and 5 is parallel to AB, and we have divided it into 10 equal divisions. So definitely 5 dash is the midpoint of line CA. We get one bigger triangle, and say another triangle is C5 dash 5. So from these two triangles, similar triangles, we can get the same relation like the previous one, that is 5 dash 5 divided by AB is equal to C5 dash divided by CA. So 5 dash, this line is equal to, this C5 dash is half of CA. So we will get half of AB. That means 5 dash is half of AB, and AB we know, that way we can measure the 5 dash, and that way we can measure any line, say 9 dash 9. This line is equal to 1/10, 199 dash is equal to 1/10 of AB, because 99 dash, that means C9 dash is 1/10 of CA, and that is why 99 dash is equal to 1/10 of AB. Similarly 8 dash is equal to 2/10 of AB. 7 dash is 3/10 of AB. Similarly 6 dash 6 is equal to 4/10 of AB. So this way we get these divisions. That means this division means 1/10 of AB, this division means 2/10 of AB. say 2 2 dash, this division is 8/10 of AB. So by using this principle, we can divide a short line into 10 equal divisions. To get these divisions, small divisions, we have to move diagonally from C to B like this. If we move from C to B, and that is the diagonal of the right angled triangle, this way we can move. So if we go to 9, from C to 9, in that we will get 9 9 days. And if we go from C to 7 dash, there we will get 7 dash 7. So that way we can divide this, and by using this principle we are going to construct a diagonal scale to show meters, decimeters and centimeters, and long enough to measure up to 7 meters when 1 meter is represented by 2 centimeters. Find RF and indicate on the scale a distance of 5 meters, 3 decimeters and 7 centimeters. We'll construct a scale like this. It will be meter here and decimeter here and centimeters this way. So first we have to find out the RF. In this problem we can see RF, we can find out from the statement 1 meter is represented by 2 centimeters. That means 2 centimeter is equivalent to 1 meter. So 2 centimeter is the length in the drawing and 1 meter is the actual length. So 2 centimeter by 1 meter, this is the representative fraction. So 2 centimeter and 1 meter is equal to 100 centimeter. So ultimately we get the RF is equal. Now the length of the scale as per definition is RF, representative fraction, multiplied by actual length to measure. Now in the problem it is given scale should be long enough to measure up to 7 meters. So 7 meters is the actual length to measure, maximum length to be measured. So 1 divided by 50 into 7 meter, 1 divided by 50 multiplied by 700 centimeter, and we get. Now we can construct the scale whose length will be 14 centimeter in the drawing sheet. 14 centimeter line is equal to 7 meter. Actual length it will represent 7 meters. So we will draw a line 14 centimeter long and divide it into 7 equal divisions. Each division is equal to 1 meter. So first division will be divided into 10 subdivisions, and after that we will use the principle of diagonal division. So first draw a 14 centimeter long line, and the line will represent a actual distance of 7 meters. 14 centimeter, yes. Actually we have to construct a rectangle, so we will draw another line parallel to this line to complete a rectangle of 14 centimeter long. The vertical distance may be of any convenient length. Let us complete the rectangle by drawing 2 vertical lines. For vertical lines you can use mini drafter or set squares. Yes, this rectangle is the base for the diagonal scale. Horizontal line, which is 14 centimeter long, will be divided into 7 equal divisions, and each division will represent 1 meter. So first locate the points at an interval of 2 centimeters, because total length is 14 centimeters, so each division will be of 2 centimeters. So we need not draw any inclined line to divide this line. So we have located the points. Now we will draw the vertical line through this point on the rectangle. That means the rectangle is divided into 7 equal parts. The horizontal length is divided into 7 equal divisions. So each division is 1 meter or 10 decimeter. Now we can mark the divisions starting with 0 at the end of the first division, then 1, 2, 3, 4, yes, 4, 5 and 6. From 0 towards the right, it will represent meter. From 0 towards the left, it will represent decimeters, like the plane scale. Although it is from 0 to 6, it is actually 7 meters because we have started from 0. Now if we have to divide the first division into 10 equal divisions, we have to draw an inclined lines of convenient angle. Let us draw a line, 5 centimeter long line, and divide it and mark them like A, B, C, D, E, F, G up to J. That means 10 equal divisions. You can mark like 1 dash, 2 dash or. So first we will join the last point J with the point 0, first horizontal line. Join 0 with the last point J. And after that we will draw all the lines parallel to this line. This is the first line, and all the lines passing through the other points A, B, C, D, etc. will be parallel to the first line. So for each point A to J, we will get 10 equal divisions on the horizontal line of the first division. So first division of the 14 centimeter long line is thus divided into 10 equal subdivisions, and each subdivision will represent 1 decimeter. Total of 10 decimeters, so 1 division is equal to 1 decimeter. We also have to divide the vertical line into 10 equal divisions. Let us now divide the vertical line into 10 equal divisions, and we have to draw one inclined line and divide that into 10 equal divisions. Let's draw a 5 centimeter long line and divide it into 10 equal divisions with 5 millimeter distance. First, let's mark the divisions like this. For this you can use divider or scale. That means we are going to divide the vertical line into 10 equal divisions. That is why we are drawing this inclined lines and dividing it into 10 equal divisions. Now we can mark these points like 1 dash, 2 dash, etc. 1 days, 2 days, 3 days, 4 days, 5 days, 6 days, 7, 8 days, 9 days and 10 days, 10 equal divisions. Now we will join the last point 10 days with this point. So this is the first line and we will draw the lines parallel to this first line passing through all the points 9 days, 8 days, 7 days and so on. We are actually dividing the vertical line into 10 equal divisions. So now we will draw the diagonal lines since this is a diagonal scale. So we can mark the divisions like 1, 2, 3, 4, 5, 6 up to 10. We can also show the even numbers only. Now we will draw the diagonal line this way. The 9th point of 10 divisions with this first point. Yes, that means this constitutes a right angle triangle and this line is the diagonal of the right angle triangle. Now we will draw all the lines parallel to this line passing through all the divisions we have already divided. Yes. Since we got the first line, we can also start from this point, 0 point also we can start. Yes. You see, in plane scale, we have to draw the vertical lines, perpendicular line, but in this case, we are drawing the inclined lines and this inclination is diagonal inclination. So now we will draw the horizontal lines for the vertical divisions. All the horizontal lines. You can use 2H pencil for this type of drawing. For horizontal lines, you can use mini drafter T square. Now this is the diagonal scale and for this there are 3 units and for the first 0 towards the left we have to mark point 1, 2, 3 up to 10. Because of the space, I am writing 2, 4, 6, 8 and 10. This 1, 2, 3 from 0 towards the right represent the meter. We have to mention the 3 units. From 0 to towards the right, this is meter. And the second unit is decimeter. From 0 to 10 towards the left. So here we will write decimeter, second unit. From 0 to 10 towards left. So this is decimeter. And the next third is centimeter, that is vertically, not exactly vertically, actually that is diagonally. For that we have to move diagonally a fraction of distance towards the left. We have to also mention the representative fraction RF, which is equal to 1:50 as mentioned in the problem. So the diagonal scale is complete. Now we have to show a distance that is mentioned in the problem. So 0 to 6, that is meters towards the right, 0 to 10, that is decimeters towards the left, and diagonally if we go, we will get centimeters. So in the problem it is asked to show a distance of 5 meters, 3 decimeters and 7 centimeters. So first we will go for 5 meters. From 0 to 5 towards right, that will give us 5 meters. Then from 0 to 3 towards left, that will give us 3 decimeters. And if we go diagonally 7 divisions, then it will give us the 7 centimeters. So if we locate the point, can see you go from 0 to 3 towards left, then diagonally 1, 2, 3, 4, 5, 6, 7. Yes, this is the point for 3 decimeters and 7 centimeters from 0 towards left. Now we can show this distance with the help of extension line, this dimension. So for dimensioning we need two types of line. One is extension line and second is dimension line itself. So this is the extension line for 5 meters and this is the another extension line for 3 decimeters and 7 centimeters. And draw one line and complete the arrowhead as per convention of dimension line as per ISI 1972. There are different types of arrowhead. You can use any of those type. Yes, this is the arrowhead in this side and towards the right, this is arrowhead. Now we can write the distance, that is 5 meters, 3 decimeters and 7 centimeters. Also we can write 5.37 meters. Same thing. That means 5 meters, 3 decimeters and 7 centimeters. So this completes the problem. Diagonal scale represents 3 units and in this example this is meters, decimeters and centimeters.